Recording in progress.
So this is the problem statement of HR analytics. So if you look at the test data is one column short, right? Sorry. So scroll down. Yeah. See here, one column short in test data, which is the dependent variable, is underscore promoted. And if you are looking at is underscore promoted, it is 0 and 1, right? HR train dot is underscore promoted dot value counts. The frequency counts, you can see here, 0 represents no. That means the employee is not recommended for promotion, and 1 represents yes, which means he is being recommended for promotion. So we have 50,140 employees who are not recommended, 4,668, which is the fair. Not all employees will be promoted. Only 10 to 12% of the organization or less than 10% will be promoted in each cycle. So we have 4,668 employees who are being recommended for promotion. How they are being recommended? Based on these variables, based on the variables which we have here, right? The department, the region, the education, gender, recruitment channel, number of trainings, age, previous year rating, length of service, KPIs met, awards won, average training score, and then the promoted of thing which is in 0 and 1. So basically, in this case, our data is in non-numeric. Our dependent variable is non-numeric. Remember, in the last session, we discussed about the introduction of supervised learning. When you talk about supervised learning, there are two sets of algorithms: regression algorithms, classification algorithms. Regression, when the dependent variable is numerical and continuous. Classification, when dependent variable is non-numeric, either binary or multinomial. Like in this case, we have a binary dependent variable. 0 means no, 1 means yes. So we have a binary dependent variable. So we can't run regression on this data. We have to run classification on this data. That is the first thing. Because in the previous class, where we have run multiple linear regression on the Big Mart sales, right? We run it. So in Big Mart sales, we have run the regression because the dependent variable item outlet sales is numerical. The dependent variable was numerical, so we could run. We have run it on Big Mart sales, or but why I didn't get? But my model says regression theory is also there, no? We discussed regression theory also, right? But where is that file? Okay. So I think I'm looking at the wrong file. I think it might be in downloads. Seven days ago. Yeah, this one, right? Big Mart sales PJ 23. Where we have done the regression theory. Okay. Now this is the classification problem, where we have to classify whether the employee will fall into 0 category or 1 category. Before that, we need to combine the train and test data sets. We need to combine train and test data for what? For pre-processing. We have to do pre-processing before we go and build a model. Now, we have one column short in test data. We have one column short. So temporarily, let us add the dependent variable to the test data. Square bracket, single quote. Make sure the name of the dependent variable exactly matches. The name of the dependent variable should exactly match. Okay, is equal to, and then I am filling that with the word test. I'm adding the dependent variable temporarily to the test data. Now, if you look at the shape, it has 14 columns, right? Because I have added the dependent variable to the test data. Why I have added? To concatenate them, to merge them into one single data frame. Now, we will concatenate. We will do row-wise concatenation. First, we will paste all the combined df is equal to pd dot concat square bracket HR train, first all rows of HR train, then HR test, all rows of HR test, comma, axis is equal to 0. Axis is equal to 0 is for row concatenation. Axis is equal to 1 is for column concatenation. Remember, axis is equal to 0 across Python is rows. Axis is equal to 1 across Python is columns. Anywhere you see axis argument, if it is 0, rows, if it is 1, it is columns. So in this concatenation, we are pasting all the rows of HR train, and below them, we are pasting all the rows of HR test. Now we will check the combined DF shape. Combined DF dot shape. So we have combined both the data frames. Now we got 78,298. See, these two we have combined into one. 78,298, 14 variables. Okay. Because otherwise it will be dual process. Whatever pre-processing you are doing on train data, same pre-processing you have to do it on test data. To avoid duplicacy, let us combine them into one and then do it only once. By doing, you can do it only once. Rather than doing a repetitive task, you can do it only once. Now, one of the first thing is missing values. We have to identify the missing values. So all of you have imported the test data. Yeah. Then combined it. So combined df dot is null. Is null is a function to identify missing values. Dot sum to total the missing values. Sort underscore values ascending is equal to false. That means we'll get the missing values in decreasing order. You can see the missing values. We have missing values in two variables, previous year rating and education. We are missing values in two variables, previous year rating and education. So 5,936 cells of previous year rating has missing values. 3,443 cells within the education variable has missing values. Yeah, 0 means no missing values. Zeros means that columns have no missing values. If there is missing values, you can see it like this. The other way of seeing the missing values is little bit experience. Once you get, you can look at the info. Now, what is our total row count? 78,298, right? Anything less than 78,298, it has missing values. Dot info command is there, right? So it says 78,298. Anything which has less than that, let us say here, education has only 74,855. That means this column has missing values. Similarly, previous year rating has only 72,362. It has missing values. Rest of the things doesn't have missing values. So you can use info command also once you gain experience. to manually check for missing values. If you want exact, then the function is is_null.sum sort underscore values. Ascending is equal to false. Top missing values on top and then 0. Or else you can look at the info command, you'll get the total here, and then you compare the total with each column's thing. Which one? Oh, dot sum for or see, it will only sum the missing values. It will sum the missing values. Is null, first it will say true or false, and then it will sum the true values. And then you can do the use the info function also to do this. Okay, now combine DF dot previous year rating dot value counts prop NA is equal to false. Now, rating scales, I told you we can't treat them as numbers. We have to treat them as categories or classes, right? Rating scales. Ratings 1 to 5. Here we have 1 to 5 ratings. We can't treat them as numbers. We have to treat them as categories or non-numeric categorical variables, because rating scales are different. They are completely different. Now, if you look at the rating scales, we have 1 to 5 rating, 1 being the lowest, 5 being the highest, and then we have missing values of 5,936. Okay, already there is a big difference, right? 26,539 employees are categorized as 3 rating. By adding this 5,936 to this, will it make any difference? No, because already there is a huge difference between the other ratings and this. By adding this 5,936 will not make any difference. We are doing a manual imputation here. So combine DF dot previous year rating is equal to combine DF dot previous year rating. What is the function? Dot fill NA. The function is fill NA. What will fill it with 3? Fill NA 3. It's dot fill NA 3. Now, if I go up and rerun the previous command again, now you can see, oh, 3.0 we have to give here, not 3. 3.0. Oh, sorry. Let me do the concatenation again. Then is null info 3.0. Okay, now let us run the previous command again. So this is numeric data. Yeah. Now that 3 all had been added to the 5,000 things have been added to this 3.0 without quotes. Float. Okay. Fill NA, give the 3.0 as float. Combine DF dot previous year rating. Fill NA is equal to 3.0. Float you give because the data is in the form of float, then only it will give. You can type it in straight line. Okay. Because there is already a huge difference between 3 rating and others. By adding this 5,000, it doesn't make any difference. Similarly, combine DF dot education is equal dot value counts drop NA is equal to false. Here also we have missing values of 3,443 and bachelors is huge. There's a huge category called bachelors, and most of the times organizations compulsorily want a bachelor's degree. So we can input it with the word bachelors. So combine DF dot education is equal to combined here dot education dot fill NA double quotes. I'll copy the bachelor's from here because there is a apostrophe S. Control C, Control V. Now I'll run the previous command. Now you can see there is no missing values. There are no missing values. So this is what we have done with the missing values in previous year rating and education. In previous year rating, we replaced it with the 3.0 rating. And in education, we replaced it with bachelor's. Assuming that bachelor's is the minimum qualification required to enter the organization. Done. Combined here dot columns. Let us look at our variables. I think we don't need to do any other pre-processing here because missing values is the only thing we can do here. Okay. Now I will split our data back to train and test. We will split data back to train and test. HR train DF is equal to, oh, sorry, we forgot the most important thing. You guys also not remember. What is the next important? Not grouping. Yes, label encoding. Or get dummies. Right? We have to dummy encode the categorical variable. We have to dummy encode the categorical variable. Now, combine DF dot D types, the data types. Employee ID is int 64, department is object, region is object, education is object, gender, recruitment channel, number of trainings, age, previous year rating, length of service, and then is underscore promoted is showing as object because it has test and the word test as well as the numbers. Now, let us split the data into numeric and object because label encoder must be run only on object data or categorical data. For dummy encoding, dummy variable encoding will be done only on object and non-numeric categorical data. Num calls is equal to combined here dot select underscore D types include is equal to np dot number. Now np.number will select both int 64 as well as float 64. That you need to remember. np.number will select both int 64 and float 64. Object calls, obj calls is equal to combined here dot select underscore dtags include is equal to square bracket single quote object. Print num calls dot shape print obj calls dot shape. So shape should be 14. The column should be total is 14. So we have 8 numeric calls and 6 object calls. We have 8 numeric calls and we have 6 object calls. Numeric is both int 64 and float 64. Both. That's why np.number is used to, because we have both int na, we have both data types, int 64 as well as float 64. Okay, so all the int 64 and float 64 will be combined into num calls, numeric calls, and object calls will take the object. Whatever is object, it will take them as object. Got it? Because we can only label encode object calls and non-numeric categorical calls. We should not run label encode or get dummies on numeric data. Now, when you split the data, sometimes some categorical calls might be in numeric calls. That you have to check. So the next step would be check for categorical variables in num calls. You have to check the categorical variables. Num calls dot columns. So we have employee ID. Anyway, we will delete employee ID. Number of trainings is numeric, no doubt about it. Age is numeric. Now, previous year rating, we have to treat it as categorical variable, right? That we have to change the location. KPIs met. What is this KPIs met? If you look at the data description, see here, it is also coded as 1 and 0. Yes or no? 0 means no, 1 means yes. So similarly, awards 1 is also coded as 1 and 0. So previous year rating, KPIs met and awards 1. These must be moved from numeric to category calls or object calls. Let us create a new thing called category calls. For our reference purposes, let us create a new category called categorical calls so that we can move them into that, and then we will drop them from numeric calls. Once you move the data from one data frame to other, please immediately drop them from the previous data frame so that there is no duplication of data. So based on the data dictionary or the data description, we found out that previous year rating is non-numeric categorical. It is numeric categorical. No, sorry, numeric categorical. Similarly, KPI is met. 0 and 1 is also numeric categorical. Awards 1, 0 and 1 is also numeric categorical. So we have to shift them from num calls to cat calls or category calls. So let us do that. Cat calls is equal to num calls double square bracket. For variable selection, double square brackets. If you remember, for variable selection, double square bracket, you can copy the variable name, previous year rating, paste it here, comma, and then the two simultaneous names, including comma and quotes, you can paste them here. Double square brackets will help you to select a new data frame. Cat calls is equal to num calls, double square brackets, and then copy paste the variable names from top, because there are some special characters involved. So that is why you have to paste them from top. Now, what you have to do immediately, num calls is equal to num calls dot drop, and then select the list of variables, single square bracket to single square bracket, comma, axis is equal to 1. Axis is equal to 1 is what? Column dropping or variable dropping. So I immediately dropping the variables from the num calls, because we have segregated them into a new data frame called cat calls or category calls. Immediately drop it from num calls so that there is no duplication of data. This step you have to do immediately. Please don't forget it. Otherwise, it will create duplication and you will have a problem. Then what we have to do, we have to just print the shapes to check whether any change happened. Shape, print num calls dot shape, print cat calls dot shape. So now you can see 6 plus 5 plus 3, 14. 6 plus 5 plus 3 is 14. 14 variables are sacrosanct. It has to be total 14 variables. 6 object variables, 5 numeric variables, 3 categorical variables. See, as per the data dictionary, previous year rating is numeric and categorical. Okay, and also KPIs met is in the form of zeros and ones. Again, numerical and categorical. 0 represents no, 1 represents yes. Similarly, awards 1 is also 0 and 1. Numerical, categorical. So we have to separate these 3 variables from numerical data, because obviously it is numbers. They will be categorized into numerical data. We have to separate them from numbers to categories. That is the process which we are doing here. We are segregating them from, we are into a new categorical columns, and then we are dropping them from numeric columns or the numeric variables. You should not treat them as numbers. They are being treated by the Python as numbers, which is wrong, because they are categories. You got it? Which one? Is promoted is an object, no? Yeah, originally it will be in because it is zeros and ones. But we have merged it with test data, right? That means there is a value called test added to it, which is text. Yeah, then we have added test. That becomes an object, mixed data type. Mixed data types are objects. All right. So from object calls also is promoted, we have to move it to numeric calls because we don't want to dummy encode the object calls as of now. Later we will dummy encode it because it has some data. So numeric call, num calls, square bracket, single quote, is underscore promoted is equal to object calls dot is underscore promoted. So we are transferring it to num calls. And we will drop it immediately from object calls is equal to so just we are relocating the variables from object to numeric. The videos are there, no? No. 4 sessions only happened, right? Till now? 5 happened, right? 23. Data processing, Excel hypothesis testing. Oh, last session I have not uploaded, right? Regression I have not uploaded. Okay, regression I have not uploaded. Huh? PGA 23. When did we have last session? But where is the recording? Recording is not there. Oh, PJ 23. How come it became MySQL session 1? MySQL for PJ 22. Documents, why it is history? That's great. Where? Fourth and we had third and fourth, right?
And we have third and fourth. And then we have
11th only, right? I didn't take it on 10th. Where did that video go? This one. This web scraping for PJ 22. How did I miss how did the video miss? Last class we missed recording. Some part of it is recording the previous class. Yeah, Excel version we missed it. But otherwise, I have uploaded everything in that one. One session we missed recording. Okay. Today's session we will upload anyway. Okay. 9 to 1. Tomorrow onwards it will be 9 to 1. Yeah, 9 to 1. No. 9 to 1. My BITS classes are over for the semester. They will again start in October, November. So till then it will be 9 to 1. Even after BIT starts also, it will be 9 to 1. Yeah. Tomorrow session will be 9 to 1. Not 11 to 3. Okay. Yeah. So object calls is in this format. Object calls dot head. See, this is our object calls, which is in the form of text. Object calls is in the form of, what happened? What are the
cat calls? We are creating the column. We're creating a cat calls.
I'll sort it out. Wait a second. Object calls is all text. Now I told you we should not have any text before we send the data to algorithm for processing. So we have to dummy encode them. Dummy variable encoding is assigning numerical identifiers to the text. Dummy variable encoding is assigning numeric identifiers in alphabetical order to text categories. So the text categories, it will do in alphabetical order. And we talked about two types of label encoding, right? Label encoder and get dummies. Get dummies is compulsory in regression, but in classification, you can use label encoder because label and classification is a completely different process. I will show you how it is different from regression. Now, these text have to be assigned numbers. For that, we have this from sklearn dot preprocessing. From sklearn dot preprocessing, import label encoder. Label encoder is a function which will assign numerical identifiers to the text data in the alphabetical order, 0 to n levels, 0 to n levels. LE is equal to label encoder. We are giving a short name. Object calls dummy is equal to object calls dot apply LE dot fit underscore transform. Now, object calls dummy dot head. Now you can see it has assigned F0, M1. If you look at the gender, it assigned 0 and 1 for F and M. For the others, it went with the alphabetical order. And then accordingly, it assigned the numerical identifiers. So this is the process of converting text to dummy variables.
None of index previous level appears in the primary columns. So, here, the number calls doesn't show it. So when they are not showing them here, how to create, you might have run the command 2 times. So first run this step. Okay, then 8 input. Then you can see it. Now you can see them. Now you can see them now. Now it will see it. Now you can drop it down. See, don't run it 2 times. If you run it 2 times, the previous one is executed, right? And already they are running it. Now it says they are not. That's what it's saying. Previous case running and all are not. So then what you have to do, you have to go to previous point where you have created the data. The latest point where you created the data. So we have created the data set. Sometimes they are going to start to do the field or installation. That's why we have to constantly have some endpoints so that we can, whenever we get this error, we can go to the nearest endpoint and whatever all will be, we get the data and do it. Okay. That's why I constantly give names, right? New names to the data and all, so that we can have an endpoint, so that we can go to the previous point and recover our data. And don't run the cells 2 times. Only once time you run shift enter or run. So dummy variable encoding, label encoder, it will assign. So same thing we have to do it for cat calls. Cat calls dummy is equal to cat calls dot apply LE dot fit underscore transform. Cat calls also is dummy variable encoded. Both object calls as well as category calls must be dummy variable encoded. Otherwise, the algorithm will treat them as numbers. If you don't dummy encode cat calls, algorithm will treat it as numbers. We don't need more numbers, we do 1 plus
0 to n levels. It starts with 0. Python starts with 0.
0, 1,
0, 1 to the alphabetical order. 0 to n levels, alphabetical order starts with 0. Python always starts with 0. Whereas R and SAS start with 1. Python starts with 0. There is a 0 variable, 0 column, 0 row in R. So similarly, the level assignment will also be starting from 0. 0 to n levels. Whatever may be the levels in that variable, it will assign them in alphabetical order. And in get dummies, it will create new columns. And then uses 0, 1 encoding. 0 no, 1 yes. Get dummies. Right. So if you are doing get dummies on same object columns dummy, it will create new columns. As many classes are there, it will create. So that is again, we have enough data here. We can do that. because we have 50,000 observations here. Even if we do get them means, I think the variable count will go to 60 or 70. 70 into 50 is how much? 3,500. But we have close to 50,000 observations, so we have ample enough data. So we can use get dummies also. Okay, so. Hmm. Hmm. Yes, you can do. Compression of categories is also there. You have to manually write an if statement, and then you have to create a category called others. And what all will fall under others, you have to specify. You have to specify using that or command. That straight line thing is there. You can do that, and you can do that. Or you can also use np.map and create a dictionaries. You remember dictionaries, key value pairs. Dictionaries are key value pairs where you can assign text and then it column numerical value. You can use that also. np.map also, which is a dictionary format, and you can assign values to it. So compression of categories, what is happening is there is a lot of work going on. Particularly Amazon and e-commerce, they have too many categories, right? They have lakhs and thousands of categories. So this categorization compression is one of the area of research. How to compress them without affecting the data pattern is very, very important. Compressions is very important. So there's a lot of research going on, but as of now, I have not seen where we can do variable compression we got in Python. Select k-fold and all are there. We are expecting the level compressions also being available in Python. In R we have. So we have some algorithms for that. Class or levels compression in R. So there is this mem compress is there. Actually, level compression is a very what you call research topic in a lot of computer science related things. Levels in capital variable. So we have this one, drop unused levels from factors, coding for categorical integration. So a lot of data is there, but I have not seen a what you call comprehensive algorithm available or a statistical procedure available. It's still done manually only. We have to manually compress. Or this factor levels in R. R has more potential than Python in terms of level compressions or class compression. So that is an advantage that it has. But that's a statistical software, right? This is only ML software. This is not statistical. All right. Okay, now we will combine them. Combine df underscore clean is equal to pd dot concat open bracket square bracket num calls comma. We have to use object calls dummy comma cat calls dummy comma axis is equal to 1 because we are doing column concatenation. Num calls, object calls, and cat calls. Where? What error you are getting? Can you read out the error in the bottom? You have not moved this one. Did you move is promoted from object calls to number? Because when you're label encoding, it should be either integer or it should be string. It cannot be both. It cannot be both. You have to drop it. You have moved it to num calls and then you have to drop it from object calls. Because a variable can be either a numeric or string, cannot be both. Okay, done. Now we got the data in clean format. Now we will split it into train and test. HR train df is equal to combined df clean square bracket combined df clean dot is underscore promoted not equal to test. HR test df is equal to combined df clean square bracket combined df clean dot is promoted double equals to test. So if it is not equal to test, that row will go into train data. If it is equal to test, the row will go into test data. Now we will drop that variable from test data. HR test df is equal to HR test df dot drop is underscore promoted comma axis is equal to 1. So we are the variable which we have added for concatenation for the purpose of pre-processing. Now we are deleting that variable because we have completed our pre-processing and we got our data back to normal shape. Okay. So label encoding, then combining them into one data frame back, and then splitting them based on train and test, and then dropping the added variable from test data. Okay. Now, split data, what data? Train data into dependent variable. Dependent variable is denoted by small y, and independent variables is x. So multiple independent variables and single dependent variable. Now, y is equal to HR train df dot is underscore promoted. X, capital X is equal to HR train df dot drop. We have dropped, we have not dropped employee ID, right? We have dropped employee ID. Don't think we have dropped. Employee ID we have not dropped, so we have to drop employee ID also. Employee underscore ID, comma, the dependent variable is promoted, comma, axis is equal to 1, column drop. Okay, now we have to label and code y. We have to label and code the dependent variable y. Y is equal to le dot fit underscore transform y. Here label and code it to the y also. Because 0 and 1 is not numbers, right? You have to treat them as categories. That's why we have to label and code y also. Because you should not treat them as numbers, you should treat them as categories. Now, our data is ready to build any classification model. Our data is ready to be built. We have cleaned, pre-processed the data, and we are ready to build any model. Now, within supervised learning, we have the other set of algorithms called classification algorithms. We have classification algorithms, which is the next set of algorithms. Last class, we talked about the basic regression algorithm. Now we are looking at the basic classification algorithm. Within the classification algorithms, the basic algorithm is binary logistic regression. Binary logistic regression is the basic classification algorithm. Multiple linear regression is the basic regression algorithm. Similarly, binary logistic regression is a basic classification algorithm. Binary logistic regression explains the linear relationship. It explains the linear relationship between a binary dependent variable denoted by y and multiple independent variables x's. Binary logistic regression explains the linear relationship between a binary dependent variable y and multiple independent variables x's. Binary logistic regression is an equation. Binary logistic regression is an equation. Like how we get an equation in MLR, multiple linear regression, right? Same way we get an equation as an output of the algorithm, and that equation will be used to do predictions. Similar to multiple linear regression, in binary logistic regression also, we will get an equation, and that equation will be used for predictive purposes. Now, what is the equation? equation is P is equal to exponential power of B0 plus B1 x1 plus B2 x2 plus B3 x3 plus B4 x4 till Bn x is the numerator part, and the denominator is 1 plus same equation we will take. So this is the binary logistic regression equation. This is the binary logistic equation. Now let us understand the components. P is nothing but probability. Now, in binary law, in classification problems, in all classification problems, we get a predicted probability. In all regression problems, what we get? We get a predicted value. In all regression problems, the algorithms will predict a value. And actual value and predicted value, we calculate the residual in regression problems. Whereas in all classification problems, the value is predicted probability. Predicted probability lies between 0 and the probability lies between 0 and 1. The predicted probability is what we get from classification algorithms. EXP is exponential. What is the exponential value? 2.718 something, right? EXP is exponential. B0 is intercept or constant. B1, B2, B3 till Bn, we call them as coefficients, and X1, X2, X3 till Xn, we call them as independent variables. This is the explanation of the equation components. We get probability as output. It will give us a predicted probability. Based on the predicted probability, we will decide. Now, how will we decide? The classification rule is there. The classification rule is probability greater than equal to 0.50 will be categorized as 1, and probability less than 0.50 will be categorized as 0. The classification rule for all classification algorithms, wherever you are predicting a probability, the classification rule is this. Greater than equal to 0.50 will be 1, less than 0.50 will be 0. Now, if you are looking at the curve, it is a S-shaped curve. So binary logistic distribution, it's an S-shaped curve. So if you look at the regression and logistic, this thing, this is binary logistic regression, an S-shaped curve. And what is the threshold? 0.50. Above 0.50 will be classified as 1. Below 0.50 will be classified as 0. Now, this is the method to calculate using vector arithmetic. Using vector arithmetic, we can do this calculation of predicting probability of y is equal to 1 given x vector and weight vector. These are vector calculations. This is very complex, but we can do it in Excel in a simple manner also. But I want you to focus on the distribution curve. It looks like a S-shaped curve, and the threshold is 0.50. Above 0.501, below 0.50 will be 0. And it will create a distinct classification, linear classifier, right? It will create a linear classifier between both the classes. So interview, they'll ask you what is the difference between a regression curve and a logistic regression curve. Regression curve is a straight line thing. And then this is your logistic regression, S-shaped curve with a threshold of 0.50. This is probability. On y-axis, you have probability. On x-axis, you'll have the observations. Okay. So this is the structure of the equation. Okay. You guys will take a break and then we'll come back and then we'll discuss further the assumptions, the interpretation and the confusion matrix, which is the important part in classifications. Now, let us go with the assumptions. Assumptions of binary logistic regressions. The dependent variable y must be non-numeric and binary. Binary means yes or no, or true or false. Second is independent variables. Independent variables can be both numeric and non-numeric. There is no restriction on independent variables, but dependent variable must be non-numeric and binary, only 2 levels. Exactly 2 levels. 3, same, there must be a linear relationship. Logical linear relationship. There must be a logical linear relationship between the dependent variable and independent variables. There must be a logical relationship must be there. Fourth one is same. No multicollinearity. What is multicollinearity? Not dependent, independent variables. Correlation greater than equal to 0.95. If 2 independent variables have correlation greater than 0.95, that means those 2 variables have multicollinearity. What we should do? We should not choose both the variables. You should choose only one variable into the model. The other variable we will discard. So, if multicollinearity found, do not include both variables. Choose one among them. Choose one among them. The fifth one. Sample size must be minimum 50 observations. 50 observations per variable. Sample size is 50. For regression, it is only 20, minimum 20, but for classification, it is minimum 50 observations per variable. Minimum 50 observations per variable. These are the basic assumptions which overlap with our regression, multiple linear regression also, right? Because this is also a regression algorithm. Interviews they ask you, is binary logistic regression a regression algorithm? Yes, it is a regression algorithm only. It is also type of regression algorithm, but it predicts binary classes. It predicts binary classes because you see, right, intercept plus beta 1 x1, the equation is almost similar to your regression only. But the outcome is non-numeric. Now, the interpretation of output in Python only. Like I told you, Python is not a statistical software, so we will not get a statistical output. What we get is accuracy, which is calculated from confusion matrix. which is calculated from confusion matrix. Now, what is confusion matrix? Confusion matrix is a 2 by 2 matrix of actual class and predicted class. It's a 2 by 2 matrix of actual class and predicted class. Okay, so confusion matrix is at the core of all classification problems. Confusion matrix is a 2 by 2 matrix. Now, actual data says actual class is positive and predicted class is also positive. Predicted class is positive. Then we call this as true positive. Actually, data says it is positive, and your algorithm also predicted it as positive. So it is correct prediction. We call it as true positive. Now, actual class is positive and predicted class is negative. That means this is a wrong classification. This becomes false negative. It is predicting falsely negative. Actually, the data says it's a positive class, but your algorithm predicted it as negative. Or simply saying actual class is yes, but your algorithm predicted it as no. That is wrong prediction, right? So it becomes false negative. Now, actual class is negative and predicted class is positive, which is again a wrong classification. We call this as false positive. False positive. Actual class is negative and predicted class is negative, which is correct classification. We call it as true negative. We call this as true negative. So these are the 4 quadrants of a confusion matrix. Now, how it looks like, I'll show you the confusion matrix. This is the confusion matrix. Actual class, predicted class. It's a 2 by 2 matrix, a 4 quadrant matrix. So actual positive, predicted positive, true positive. Actual positive, predicted negative, false negative. Actual negative, predicted positive, false positive. True negative is both actual negative and predicted negative. Now, what is accuracy? True positive plus true negative divided by all 4. This is the formula for accuracy. The primary metric is accuracy. Like RMSE is there, no? Sorry, R square. We have R square in regression. Here it is confusion, accuracy. Accuracy based on confusion matrix. This is the formula for accuracy. True positive plus true negative divided by true positive plus true negative plus false positive plus false negative. And false negative is called type 2 error. False positive is called type 1 error. Now, false negative is more dangerous than false positive. Take, for example, a patient went to a COVID test and test says negative. Test result came out negative, but the person has actually COVID. So what he will think, he doesn't have COVID, he will negligently be there and he will ignore and it will become a life-threatening disease and he might die. Because the test has given falsely a negative report. Now, person went for a COVID test, he did not have COVID, but the test said positive. What he will do? He will immediately go to the doctor, take some medications. He will suffer from some side effects, but he will not die. So false positive is less risky compared to false negative. In medical data and clinical trials, the false negatives are very, very dangerous. Even today, RT-PCR test has close to 30% false negatives. It is not 100%. Antigen is worst, 75% false negatives. The antigen test which you can do at home, it's a big fraud. It's a big fraud in the medical industry. Particularly the antigen test, 300 rupees kit, you can go home, you swipe, put it in the thing. That's the biggest fraud. Because it always gives you wrong result. So even RT-PCR, which is a formulated test, every test, not only that, every test has a false negative. There is no diagnostic in the world which is 100% accurate. No diagnostic. Right? So it is not 100% accurate. Even blood sugar levels, they are not accurate. The AccuCheck one is not accurate. Even the manual one done and then weighted also is not 100% accurate. BP machines, which give you the blood pressure, 100, they are all based on algorithms, right? All these things are based on algorithms. Wherever you have algorithms involved, it is not 100% correct. Because you will always have an error. Predictive error will always have something called irreducible error. Irreducible error means you cannot avoid it. Why can't we avoid it? Because we don't know it exists. Did we know COVID existed 2 years back that it will cause so much of problem? Now in financial markets, that has become a big issue now, pandemic. All the financial forecasting, stock markets, Bitcoin, gold prices, crude oil prices, till COVID came, nobody bothered about pandemics. All they were bothered about was earthquakes, cyclones, and typhoons. That's all they are bothered. Because earthquakes create large-scale destruction, cyclones and typhoons come regularly every year, and then in some regions they create big problem. But now, even worse than them is COVID. Completely shutting down the supply chains. Created havoc. Right. Even today, we are not 100%. Supply chains are still struggling. So we will always have some sort of error. Because we can't model all the factors. There are factors which are not known to us as of now, which might emerge at later period of time. So there will be always an error. That's why in statistics, we say 95% only. Leave the 5% for that unpredictable errors. So we can't say 100%. It is always 95% confidence levels. So now, if you look at the primary metric, like I told you, accuracy is the primary metric. What is accuracy? Accuracy is equal to TP plus TN divided by TP plus FN plus FP plus PA. This is the accuracy. This is the primary metric. And the range for accuracy is 0.702 to 0.95. R square is 0.60 to 0.95. In regression, here it is 0.70 to 0.95. We want the accuracy to be between 0.70 to 0.95. Less than 0.70, underfitting, model has failed. Greater than 0.95, overfitting, too good to be true. Too good to be true. We have to look at the models. So this is the one. Now, the other metrics which are important are sensitivity is very important. If you look at sensitivity here, true positive by true positive plus false negative. Sensitivity also called as recall. The other name of sensitivity is also called as recall. Then precision. Now precision is true positive by true positive plus false positive. Precision is true positive by TP plus FP. So if you are looking at sensitivity or recall, it is TP divided by TP plus Fn. Whereas precision is TP divided by TP plus FP. Sensitivity, precision, and then one more metric called F1 score. F1 score, which is basically two into precision into recall, precision into recall divided by precision plus recall. F1 score. Let me just check F1 score. Two into precision into recall divided by precision plus recall. Yes. Now, these metrics are important for imbalanced data. Imbalanced data. Imbalanced data means there is huge difference in the two classes. Like in this case, no is how many? 50,144. Yes is how many? 4,668. That is classic example of imbalanced data. When you have imbalanced data, you should not go with accuracy. For imbalanced data, accuracy will be very good. But when you look at this precision, recall, and F1 score of the minority class means smaller class, they will be very, very bad. So on normal data, we will go with accuracy primarily, but we also check the sensitivity, precision, and F1 score. Because if there is minority class involved, that minority class will have worst predicted metrics. Majority class will have 0.90, 0.95 like that. Minority class will have 0.20, 0.40. Worst predictive probabilities will be there. So all the metrics of confusion metrics are very important in case of imbalanced data. But if the data is balanced, we can go blindly with the accuracy of the model. So this is one thing which you need to understand in confusion matrix. So the classification algorithm in Python in the backend will automatically build a confusion matrix and will give you the accuracy as part of the score. Dot score is there, where we get R square in Python regression. Here we get accuracy. Accuracy, we get it as dot score here. I will show you how it is computed. And then the confusion matrix is the fundamental of the all classification models. For all classification models, confusion matrix is the fundamental. Okay. And we get the accuracy and we get the intercept and coefficients. The output we get in Python is intercept and coefficient. We get the accuracy. Second thing we get is the intercept and the coefficients to create that equation, which I created on the top. We will get the intercept and coefficients. Okay, so this is the confusion matrix, which is very important. But as we progress, I don't want to pressurize, once we go through the classifications, we also have to study something called AUC, area under the operating curve. AUC ROC score is also very important, which is based on TPR and FPR. This is also important, which is very important here. If you have AOC between 0.9 and 1 is excellent, 0.8 to 9 is very good, 0.78 is good, less than 0.5 is unsatisfactory. The dotted line is less than 0.5, that is the 0.5. We'll study, I will tell you how to calculate this and all, we'll study this at the later stage, but this is also an important metric. So ROC curve or AOC curve, which is done using true positive rate and false positive rate. The formula is based on TPR and FPR. So using this TPR and FPR, we calculate the AU ROC. So this curve is easily done in Python, but we look for this curve as a example in some of the diagnostics. We will have the so if you see TPR, TP by TP plus Fn, which is nothing but sensitivity. The other name of sensitivity is TPR also, true positive rate. Sensitivity, recall, or true positive rate. FPR is false positive rate, which is FP by FP plus TN. And using these two metrics, we plot the ROC curve. And this curve is a very important curve when you are dealing with AOC and all. For some banking models and all, ROC curve is important. But if you're looking at e-commerce data or retail data and all, we are not that bothered about the ROC curve. But in banking and financial services and all, we talk about this ROC curve. I will explain at later stage once we go into those data sets in detail how to do this. Okay. So as of now, we will focus only on confusion matrix. That is our primary agenda. So this is your structure of confusion matrix, a 2 by 2 matrix for a binary data, n by n matrix for a multinomial data. If you have more than 2, it becomes a multinomial data, and it becomes a n by n matrix. It becomes a n by n matrix. Okay, any doubts? Now, this has all the things. Anyway, I'll share the notes with you, both as PDF file as well as the IPNB notebook. Okay. Now, let us run the logistic regression. From sklearn dot linear underscore model, import logistic regression. Logit is equal to logistic regression. Logit, I've given a short name to the logistic regression. Logit model is equal to, we are fitting the model here, logit dot fit x comma y. Oh, we got an error. So it says, the error says convergence warning. Convergence warning means all the coefficients could not be calculated. We have the betas, right? If all the coefficients are not calculated, then we get this convergence warning. Now it says total number of iterations have reached the limit. So you have two options, increase the number of iterations or scale the data. Scaling means, remember, standard scaling, x minus mean divided by standard deviation or normalization. We talked about data pre-processing, right? Scalings, min-max scaling or a standard scaling or robust scaling, something to do. Now, at this point of time, scaling is again, you have to go back to pre-processing and doing it. Rather than that, it is giving an option called increase the iterations. Now, if you go to the sklearn logistic regression, see here, the max iterations is 100. Now it's very easy to increase the iterations and it will not affect our computing power also. So we'll go with the first. So the error pointed out that convergence warning. Convergence warning means all the coefficients are not calculated or all weights were not calculated of the model. And it is suggesting two things, increase the number of iterations or scale the data. So I will add in the log max underscore iter is equal to 1000. We are increasing the iteration. See, it's an iterative model. Okay. it needs iterations to fit what we call maximum likelihood estimate is the model which we use, which is an iterative model. It runs multiple models. Now, you have any idea of solver? In Excel, do you know solver? If you remember your +2 mathematics, we use random numbers to solve equations. Somebody will assume some random number and then start working the calculation. If it reduce the number further. Yeah, if it increases, then you have to adjust the number and all. We call that as solver or optimization. We call it as basically optimization. Now, this optimization, in Excel, we have solver. In Python also, we have the same optimization. What solver will do is, you fix an error. You say, I want this error to be reduced using these coefficients such that I get the coefficients with the least error. So what Excel do, it runs iterations with different combination of coefficients, and then it will adjust the error. And after doing these iterations, it will come up with a particular error. Now, if there are not enough iterations, it might not reduce the error totally. So it is always better to give more iterations so that it will stop early. If at all error cannot be reduced further, it stops. So we have in Excel called solver. Solver will do it. Optimization, linear programming, we use that optimization, right? Maximization and minimization programming, dual simplex methods and all are there, right? Similarly, we have a solver method, linear programming. So logistic regression uses that methodology to solve. So I will show you the method. When you are using solver, it has iterations. It iteratively reduces the weight such that the overall error also reduces. So when it doesn't have enough number of iterations to do that, it cannot proceed. Then the warning will set. Now 1000 iterations are enough. Now it has fit the model. Now let us see the score. Score is nothing but X, Y. 91.72. What is the score? This is the accuracy calculated from confusion matrix. In the back end, it has done a prediction and it calculated the accuracy from confusion matrix. 91.72. Now you can check it also, whether you can also check the accuracy of the model by plotting the confusion matrix also. So say logit predict, or let us first go with the required equation. What do we need? Logit model dot intercept. We need intercept for the equation. Intercept is -6.78. Logit model dot coefficients. These are the coefficients. Now, one second, pd dot data frame x dot columns, comma, logic model coefficients. I will got another. Index data must be one dimensional. Columns is equal to x dot columns. See, we got the coefficients. So coefficient of number of training is -0.18, -0.02, 0.24, 0.04, these are the coefficients with which the equation will be created, like how I showed in the top now. So the intercept and the coefficients are there. It will create an equation that looks like this. This. The intercept, the betas, we got the values, they will be replaced and the x1s will change. Every row will x1, x2, x3, it will change. And when you solve this equation, you will get something called predicted probability. And based on the predicted probability, you will get 0 and 1 categorization. So this is the intercept and the coefficients for the equation. These are the intercept and the coefficients. which are required to create that equation. Now, the predict function will do it for you. Logic predict is equal to logic model dot predict of X. Logic predict of X. For all the observations, we are doing the prediction. We have 54,000 observations, right? We are doing the predictions. PD dot cross tab Y comma logic. We got the confusion matrix. Now, these two are correct predictions. These two are wrong predictions, right? These two are two correct predictions. 49,948 and 325 are wrong predictions. These two are, right predictions. These two are correct predictions. These two are wrong predictions. This is actually 0, predicted 1. This is actually 1, predicted 0. So 448 plus 325 divided by 49,948 plus 192 plus 4343 plus 325, 91.72. Exactly same to the decimal which you got on top. Right, 91.72 is the decimal you will get. So as part of the process only, it will predict on the independent variables and it will give you the predicted value. So intercept, coefficients, then we predict, and then we use the confusion matrix to get it. You can do the confusion matrix here, logic model dot intercept, and then coefficients, and then the confusion matrix. This is the confusion matrix. So in our case, 0 is positive or 1 is positive. Why we are using positive, negative instead of yes or no? Because based on the problem, the positive, negative will change. In this case, which is positive? 0 is positive or 1 is positive? 1 is positive, 0 is negative. Credit card fraud. Credit card fraud. Customer has defrauded on credit card. Yes, 1. Credit card fraud, no, 0. There, which is positive? 0 is positive. So the positive and negative depends on the problem statement you are dealing with. Loan default. Customer has defaulted on loan. Yes, 1 will become negative. 0 becomes positive. So you have to understand the business statement, problem or the business objective, and then you should decide which is positive and negative. Accordingly, you will be getting here. Here, our true false negatives are very high. 4343 is false negatives. So promoted candidates, it's predicting it as very less. So the model somehow has a problem in predicting the things because of the imbalance. There is a huge imbalance between the yes category and no category. So later stage, maybe sometime in the last week of October or early November, we will go into imbalanced data methods, where we balance the data. We have an algorithm called SMOT, synthetic minority oversampling. We will use that model on this data, and then we will try to balance both the classes, and then we will do random undersampling, we will do oversampling, we will do SMOT NC, SMOT C. A lot of algorithms are there for balancing the data. So that time also we'll work on HR analytics. Got it, all of you? Now, if you want to see other metrics, all of you have done till this point? Got it? All of you got to this point? See, this is our confusion matrix and accuracy. Now, if you want to see other metrics from sklearn.metrics, import classification report. print classification report Y, comma, logic predict. You got the precision, recall, and F1 score. And also the accuracy. Accuracy is 92%. Very good, right? But look at this. Look at the problem there. Recall for positive class is recall for one class is only 0.07. That means that is what is happening now. It is not predicting the promoted candidates correctly because the recall is very, very low. Worst. It should be above 0.70, right? But it is 0.07. Look at F1 score. Obviously, if your recall is down, your F1 score will also be down. This is what you will have to check in imbalance. Look at accuracy. Accuracy is very, very good. If you go by accuracy, it is really good. But what about the minority class prediction? The minority class prediction is very, very bad. Majority class, perfect. No problem with that. So it is predicting who will not get promoted correctly. It is not predicting correctly what? Who are eligible for promotion. What are the likelihood candidates who get promoted? That it is failing to predict. What is the purpose of our model? We want to identify people who are going to get promoted and make sure that they get promoted. So, but the algorithm is failing to do that. Why it is failing to do that? Because it has less sample available for promoted employees. It requires more sample for promoted employees. If it gets more sample for promoted employees, then it will improve its predictive accuracy. See, this imbalance problem is a problem for classification algorithms. Because how many people will default on credit card? RBI says if you have double-digit default, that means more than 10% customers default on credit cards, RBI will immediately say stop issuing credit cards. So banks will maintain credit card fraud at 5 to 6%. That means 95% people will pay. Obviously, you'll have an imbalance. How many people will default on loan? 8%. Of course, post-COVID, it went up to 16 to 20% also, but that's a scenario which is acceptable. But generally, less than 10%, RBI says your defaults have to be. So obviously, in classification data, you will have imbalance. Even if you look at COVID X-rays, if I talked to the guys in care hospitals, Nampally, they said we do X-rays of 600 to 700 people in a day. COVID confirmation will be given for only 140 to 150 people. Rest of the 550 people X-rays will be clear, no problem. So obviously there also we have the same problem, undersampling or less available things. So we have to augment the images. We call it as data augmentation. So we will create more images from the COVID images. X-rays, we will try to create more, duplicate more images by adding rotations, flipping, something. Not exactly same copy. Data augmentation methods are there, algorithms are there, which use flipping, blurring, what we call cropping, all those methods are used and they create new data, synthetic data. And then we prop up the samples and then we will do the algorithm. See, that happens. If cancer diagnosis is done for 1 lakh patients in a year, hardly 500 to 400 people will be diagnosed with cancer. Does everybody get cancer? No, right? It's even very, very small percentage of people who are diagnosed with cancer every year, at least in India. But in US, it crossed 1,000, which is now a concern for them. In a 1 lakh diagnosis, in case of US, it is above 1,000. I heard it is close to 2,000. Government is not accepting it, but the diagnosis is now getting close to 2,000. That means it's a very big thing, right? 2% people are getting diagnosed with cancer means it's a very big thing. With government, their government pays the bills, right? Not like in India, where we pay the bill. Their government cost will increase. Medical costs will increase. Already UK is suffering from NHS. Same problem. Cancer and other things are causing NHS, National Health Services, to fail. So these all things are there. So in healthcare analytics, we need to predict what would be the cost, what will be the budgets, how we should manage, which diseases will come up. All these models are there and algorithms in the field. Now, the new flu which is coming in US is predicted 3 months back. Governments know 1 year before what type of weather forecasting. We can forecast cyclones for next 3 years in India. At least we got that algorithm from Russia or someplace. Indian Met Department is doing it. We know when cyclones will come in the next 3 years. Which side, East Coast, West Coast, and all. Accordingly, government will prepare disaster management policy. Now, if it doesn't come, it's good. But you are prepared, no? If it comes, you are well prepared. That is why in India, cyclone deaths are very less. Because India has adopted this algorithm long back, where we predict and prepare ourselves for disasters. But we have a problem. The problem is with Himalayan disasters that no algorithm can predict. Uttarakhand, Himachal Pradesh, they are causing big problem. The algorithms are not able to predict those things. And most of the deaths are happening there. We have floods in Andhra, right? But anybody did? No. Government was well prepared. Government was well prepared. The Godavari floods as well as the Krishna floods, Kaveri, Penna, all floods happened in the last 3 months. People didn't die in AP, Telangana, or Karnataka, or Tamil Nadu because government was well prepared. But what happened in Himachal, Uttarakhand? People died. Their predictive accuracy in Himalayas is we are not able to get because it's a unique system, right? That's very what we call unpredictable thing in Himalayas. Even tremors, the earthquake tremors, no? Which is constantly measured. US always blames India. You are not collecting the data properly. Because Americans are more bothered about the Himalayan earthquakes because they have people in Pakistan, right? Their military and aircrafts and all are there. And if anything happens in Himalayas, Pakistan is more affected than India also. India also will be affected. But Americans are more bothered about their people in Pakistan and Afghanistan. They will always say, you have to collect the tremor data correctly. Because then only the algorithms will predict, right? So everything is collected and everything will give you these things. New York City recently implemented crime prediction algorithms. They are running it on people. But not on all people, only on criminals. Released criminals from jail, they are tracking, which is violation of privacy, but still they are doing it. People who are released from jail, they are constantly monitored by New York Police Department. And the algorithms will keep on calculating what is the potentiality that, what is the probability that he will commit crime. Which type of crime he will commit also is predicted. So that sort of things they are doing. Behavioral analytics. I have seen that algorithm in GitHub somewhere, some guy was presenting. We can predict human behaviors. So these algorithms, if you tune them properly, if you get the right variables, they will give you wonderful results. Classic examples: Netflix, YouTube, Amazon. They are all data crunching companies, right? They all depend on data only. Amazon, how accurately it suggests the what you call the accessories or the other products, recommendations, the reviews, and they have one of the highest purchase rates. They have one of the highest purchase rates in e-commerce industry. That means a person logins to Amazon, he will complete the transaction and come out. That we call it as purchase intention rate. Amazon has the highest in the industry. Initially it was Alibaba which was having it, but now Amazon beat Alibaba. Now Amazon is having the highest purchase intention rate. They're not disclosing it, but they have the highest rate because they know the person's behavior, what he is searching, what is the probability of his buying the product, and accordingly they will give offers. And offers keep on dropping, right? Purchase also will come up, suggestions, reviews. Even if you shut down, you'll get a mail. Right? You'll get a mail suggesting to getting an offer or something else. So everything is done by algorithms, no human intervention. YouTube, classic example. If you are searching for a topic, all the relevant topic videos will come. We call them as recommendation systems. We call them as recommender systems. We'll study recommender systems also. The ALS algorithm, which was developed by Amazon and Netflix, alternate least square method, which is the based on singular value decomposition. It crunches the data very fast. It crunches the data very fast. The Amazon algorithm knows whether you will buy it or not. That sort of fast thing, it looks at it. And if your system allow the camera and all to Amazon, they will study your facial recognition features also, and they will look at the intention of your buying. This once you go deeper into algorithms, there is no privacy. First of all the data we crunch. All data is crunchable. Anything available on internet, you can get it. You can use it for any type of decision analysis. As long as it doesn't appear on internet, the data is safe. But it appears on internet, it will be analyzed. That's why governments don't give the data. Because if it comes out, you can easily find it. 10th class guy also will find out the anomalies in the data. We call them as anomalies. Anybody can find out. With a simple comparison of two numbers, you can find out what is the anomaly. Okay, so hypothesis testing, let us do. You have the Excel sheet, right? Of the this method, what we call HR analytics train data. Did I work on train data for do we have this Excel sheet? Train data. Yeah, we have. Okay, 1 second. While you all have this data, right? Save as Excel workbook. Save it in desktop. I'm saving it as Excel workbook. Save the data as Excel workbook. Save the data as Excel workbook. If somebody on the AC, check sometime. Put it on 26. Save the data as Excel workbook. Save the data as Excel workbook. So I will take some numeric variables, number of trainings, age. Will be, I will also take length of service, numeric variables I'm taking. And I will also take average training score and ease promoted. Average training score and ease promoted. Now make sure there are no gaps in between the variables. No column gaps should be there. Age, length, average training score, and ease promoted. Let me zoom it to 150%. Is it okay? All of you can see? Just select these variables: number of trainings, age, length of service, average training score, and is promoted. And what I will do is I'll copy this, except is promoted, the independent variables. Control C. I will come here, and transpose. I will add intersect also. here, intercept coefficients. Okay, intercept and coefficients. And I have taken these variables: number of trainings, age, length of service, average training score, and is promoted. Okay, so I have taken these variables. Let us randomly assume some coefficients, 0.05. I'm just randomly assuming some coefficients, 0.05, 0.05, 0.05. Okay. Now, let us calculate the value of Z. What is Z? Is equal to intercept. Fix it by pressing F4 plus coefficient of, fix it by pressing F4 or Fn plus F4 multiplied by number of trainings plus coefficient of age, fix it F4 multiplied by actual value of age plus coefficient of length of service Fn plus F4 multiplied by actual value of length of service plus the coefficients must be fixed by pressing Fn plus F4 into the actual value of training score. So the coefficients must be fixed by plus F4 because they are constant, they are same for all the cells. They are same for all the cells. So I will get the, and I can double click the formula, it calculated for all the cells. So this is the formula which I've used. Intercept plus coefficient of number of trainings multiplied by the actual number of trainings, coefficient of age multiplied by actual value of age, coefficient of length of service multiplied by actual value of length of service. The coefficients must be fixed with dollars. Fn plus F4, most of the laptops, there's an Fn button on the left side, Fn plus F4. And multiply the coefficients with the actual data of all the rows. Since coefficients are common, the cell values should not change. See, even for this row, the coefficients remains the same. That is why we are using absolute cell referencing. This we call it as absolute cell referencing, where the cells will not move. Even if you drag the formula, the cells will not move. Okay. Once you calculate Z, we calculate sigmoid of Z. Sigmoid of Z is nothing but 1 by open bracket 1 plus exp minus Z. 1 by 1 plus exp minus Z. The same equation which I have shown in logistic regression, the shortest form is e to the power of Z divided by 1 plus e to the power of minus Z. What is Z? Intercept plus beta 1 x1 plus beta 2 x2, that will put it under Z. E to the power of Z divided by 1 plus e to the power of minus 1 plus e to the power of Z. Then we call it as, it becomes 1 by 1 plus e to the power of minus Z is equal to 1 divided by 1 plus exp open bracket minus this Z value. 1 by 1 plus exp of the Z minus Z value. One by 1 plus exp minus Z. Now, these are all the probabilities. These are the probabilities which needs to be adjusted with the weights. 1 by 1 plus exp minus the cell value of z. And then double click the formula, it will calculate for all the cells. Then we've got the log likelihood function. Log loss function for logistic regression images. Let us see what is the log loss function. Y into log of p plus 1 minus y into log of 1 minus p is the log loss equation. You have a simpler equation. And this is the simplest one. Paste special objective. Okay, so let me reduce it into smaller size so that you can see the complete formula. Okay, so we have to calculate log loss is equal to y. Y is our dependent variable. Y into log normal of probability. This is the probability. Plus open bracket 1 minus y into log normal of 1 minus probability. We have to give complete bracket starting to end. Double click, it will calculate for all. You can add minus also here, because then it will become positive. Otherwise, it will all be negative, na? We can't do anything. So we will add minus in the beginning only. Otherwise, some people add it when when they are multiplying it, they will add it at that point of time. But we can add it before here only, as per this equation. So you got the equation, right? Minus open bracket y into log normal of p, where p is your probability, which is 1 by 1 plus e to the power of minus z, plus 1 minus y into log 1 minus probability. Okay. And then you double click the formula, it will give you the things. Now, you want the formula? Y is promoted. Y probability and log normal. Only three things. I will sort it out. 1 second. Yeah. Now, sum log loss or we can say average log loss is equal to sum of log loss divided by count of log loss. Okay, why I am not getting the value? Okay, sum by count. Okay, this is the one, right? Now, what I will do is I'll go to the data tab, analysis tools, solver add-in. Oh, I didn't add solver. Solver is there. So we got the solver. So objective cell is log loss cell. We want to minimize. By default, it will be maximized. You have to change it to min. By changing the cells, by changing these cells, unclick make unconstrained variables what you call non-negative, GRG non-linear, and click on solve. So if you can see here in the bottom, it is running the trial solution 8, trial solution 12. You can see in the bottom, this section, trial solution 15, 19. It is running the iterations. And you can see the values are done. It is done. Keep solver solution, click OK. Now see the coefficients have changed. And look at the probabilities. Earlier, all probabilities were 0.99, right? Now the probabilities also got adjusted. Now, look at the average loss, it is also reduced. This is the intercept and the coefficients. Right. Just give me a second. So what are the variables we have used? We have used what variables? Just give me the variable names. X2 is equal to char train df, double square bracket. What are the variables? 1 second. Why I'm doing this? A chart train df dot columns. Copy paste is there. No? Number of trainings, age, length of service, right? And average training score. These are the variables, right? Why it is coming like yeah. Now we got the X2. Okay. Logit model 2 is equal to logit dot fed X2 comma Y. Logit model 2 dot intercept minus 5.06. Did I get the same thing in Excel? See, minus 5.06. And the coefficients. PD dot data frame logic model 2 dot coefficients comma columns is equal to x2 dot columns minus 0.244. See, to the decimal. Minus 005327, 002718, slight difference 0.047163. See, only decimal rounding of error. Exactly same process is used in here. Now, all of you calculated till here and then did the log loss. This is the formula for log loss. I'll help you out. No, bracket one. So the bracket should start from one before. There is no bracket after before it. That is that. Okay. Bracket. One by open bracket 1 plus AXP minus we are just using this function. Like in regression, we have that x transpose multiplied by x to the inverse into x transpose, right? Where we get that function. That is the function for regression. X transpose multiplied by x to the inverse and x transpose. Similarly, for logistic regression, this is the log loss function we have to use. Minus into y into log normal of p probability plus 1 minus y into log of 1 minus probability. Like in regression, X transpose multiplied by X to the inverse matrix, multiplied by X transpose multiplied by. We can use matrix, there is a matrix formula also. Similar to like that, but it's very complicated. Compared to that, this log plus formula is. And then once you calculate the log loss, this is sum by count, average log loss. Sum of the log loss column divided by count of log loss. You get the average log loss. Then using the solver, fix this cell, minimize. By default, it will maximize, convert it to minimize this cell, and then by changing these cells, unclick that make unconstrained variables non-negative, unclick it, and then click on solve. It will solve and give you the final solution. This is the final solution. Now, same methodology is used by Python. In our methodology, slightly changes. It uses the matrix formulation. In case of Python, solver method is used. Even we can create a confusion matrix. By doing the predicted class here, we can do confusion matrix also. That will be exactly matching the Python confusion matrix. So knotted inverse, remember that, but while you're working, when it is not fitting, you need to understand mathematics. So when it will not fit, when it has a problem in this log loss function. When the log loss function create NA values or infinity values, then the logistic regression will not work. Sometimes you get infinity values or those values, divisible error values. That time, because these are very complex calculations, logarithmic calculations. So you have to be very careful. And one more thing is we don't scale the data that much here, but scaling is again suggested in Python. For this formula, scaling is okay. But matrix calculation, scaling will be a problem. Formula for log loss is. Is equal to minus open bracket E is promoted multiplied by log normal of 1 plus probability plus 1 minus E is promoted into log of probability. 1 minus probability. That 1 by 1 plus EXP minus Z is the probability. Right? Which is the short form of the regression, logistic regression equation. We call it a sigmoid. When we study neural networks, we'll come across this formulation, sigmoid. Sigmoid is nothing but logistic regression. Now we will get different log loss. Don't go with it because it's solve solution. You will get 4.74 something. Because I have already run the solver, so my log losses will be different. So please don't compare with these log losses. Okay, can you write the email again? So we can add it to the drive and the email.
Tomorrow we will do a pre-processing session or we'll go to the next set of algorithm. Both data subject in new data. Because from next set of algorithms, we call them as both classification and regression algorithm. Next is decision tree, which works as both regression algorithm as well as classification. Decision tree is the next algorithm. Tree-based algorithms.
Now, who is giving the data on the table?
Yes.
So, just we need to.
No, practice makes we work on a new data set. Right from the beginning. There's a lot of time for us, no problem. We will cover all the things. So these calculations help you when the model is not fitting, not that you have to remember, not that they will ask you interviews and all, no. These are the things which you need to know when something is not working. You should be able to answer, right, why it is not working. That scenario, you will have to understand the equation. Otherwise, it is not required. Just for your mathematical knowledge, since I have to teach the maths, I like teaching maths and stats both, so I'll keep it. Just an equation, right? If you are having a little comfort with Excel, I am telling you Excel is best for machine learning rather than Python and R. If you know Excel, it is very easy to do the calculations. Okay? You are able to do it, all of you? Or any help needed? Not done? Although you read added earlier, now go to file, options, more. Add-ins, last button. Click on go, manage the Excel go. Click on go. Click on for last one. Click on. Do that. Now, click on solve. It automatically, click on the select this, right? Minimize. Click on the arrow, select the coefficient. And take that and click on solve. This one is the right solution on that side. And it is. Click OK. You are in another. Sigma and there are some general letters to that. Where sigma the coefficient of the system. You have a problem of its solution. No, it should not be promoted. Select the tablet also. Now go to solve it again. Do it. 0.01. Okay, now do it. Okay, now do it. Forward. Exactly. Now, what I will do, only marginal decimal change. That's all. So random number selection is given, no? So then the marginal number to add, we can give that is.
Now, if you want to create confusion matrix, you need to predict. Is equal to if greater than equal to 0.50, comma 1, comma 0. This is the predicted class. If statement. Okay. Now I'll copy the actual, Control C, Control V. I'll copy the predicted, Control C, home, paste special values and number formatting. Okay. Now insert pivot table, table range, existing worksheet, click OK. Just select some table range. Okay. Okay. So E is promoted to rows, predicted to columns, drag any one of them to values, change the settings to count, click OK. You get the confusion matrix. Hey, why we got only 0 and 1? Hey, we got only, I think small data, it is not able to predict. Small number of variables. Field settings, count, click OK. We didn't get a proper confusion matrix. I think same thing should happen in Python also. Logic model 2, predict, is equal to logic model 2, predict, x2. PD dot transfer, logic model 2 predict. Yeah, same thing. Because we don't have enough variables, no? The problem is enough variables are not there. So here also we are getting the unitary matrix. It's not able to create a confusion matrix. Same thing happened in Excel also. I copied the data into Excel sheet, created a pivot table. I also got the same thing here. See here. It was not able to predict the classes. So because of the data problem, we have taken only numeric variables, right? That is the problem. So this is the process of calculating the logistic regression, which is followed by Python. Now R uses a different formulation. R is a statistical formulation. So what R uses is a different one. So statistics is different, right? I told you. So logistic regression, binary matrix law. So here is the formula. This is the formula. For logistic regression, this is the formula. So B is a vector of logistic regression coefficients. You have to predict there. W is a square matrix of order n. So you can see here B1 coefficient 1 is equal to beta naught plus x transpose into weight into x to the inverse multiplied by x transpose into y minus mu. Mu is the vector of length of n elements. So this is the matrix formulation, which is which is more complicated compared to our log loss. Log loss is better. But in case of R, it uses this method. Because this is statistical. From this, you can calculate this. You can calculate the pseudo R square. You can calculate the McFadden's what called Efron's R square, McFadden's R square, log likelihood ratio. Log likelihood we have calculated, na? Y into log. We use this only. We use this only to calculate. And then from that you calculate 2 into log likelihood this thing. Then you have the wall statistic. These are all statistical. When you do it in SAS or when you do it in R or SPSS, you will get these statistical outputs. You won't get them in Python. When we go through R, we will go through these things. Wall statistic or wall test. See, all these things will be. Okay. We'll end this session.